Since the dot product produces a scalar, we could also think of the dot product under this interpretation. U dot v would be equal to the magnitude of u times the magnitude of v times the cosine of theta, where theta is the angle between the two vectors. This could be reversed to say that theta is equal to the arc cosine of u dot v divided by the magnitude of u times the magnitude of v. Now, what does this formula tell us? Two vectors are considered perpendicular or orthogonal if their dot product is equal to 0, because this theta would be equal to 90 degrees. So therefore, the two vectors would be perpendicular. So we write this that u is perpendicular or orthogonal to v if and only if u dot v is equal to 0. Now, let's suppose we have two vectors. We have this v vector here, and then this u vector all the way out here. And we have this theta angle between them. We could ask ourselves, how much does v point in the direction of u? Or what piece of v is in the u direction? Well, the answer to the first question is that the length of this line right here is called the scalar projection of v onto u, because we look down and we project this line onto the line of u, which we could also write as the component of v onto u. The component of v onto u, because it's on top of u. So how would we be able to figure this out? Well, trigonometry tells us that this is going to just be equal to, because we're looking at this part right here, this is going to be equal to the magnitude of v cosine of theta. And since we know that u dot v is equal to the magnitude of u, magnitude of v, cosine of theta, that we know this is going to therefore also be equal to u dot v over the magnitude of u. Notice that this number is going to be negative if theta is greater than 90 degrees. So this answers my first question that I was asking. How much of v points in the direction of u? Because we're just looking for the magnitude there. Because, right, this produces a scalar, this produces a scalar. So the component of v in u, that's just a scalar. It's just a number. So that's how much of v goes in the u direction. So what was my second question? What is the piece of v in the u direction? Therefore, we need to think of this as if, what if there was a shadow on the line u? What would that vector look like? What would be the vector of that shadow? This is called the vector projection of v onto u. This is a vector that is parallel to u, and its length is going to be the component of v in the u direction. So how would we do this? Well, let's think about this logically. We want this projection, which we'll write projection of u, of v onto u. Well, we want it to have a magnitude of the component of v onto u, but we want it along this u vector. So we'll multiply it by u. And now it's in this direction. But this is component of u component of v onto u times the magnitude of u. We only want the magnitude of this whole thing to be the component of v onto u, so we need to get rid of the magnitude of u. So we just divide this by the magnitude of u. You just do what seems logical there. Now we already know the component of v onto u is equal to this right here. So we could also say that the projection of v onto u by replacing our formulas is going to be equal to u dot v over the magnitude of u squared, all of this times the vector of u. Now, knowing all this, what if we were given the example? Find the vector projection of v onto u, given this being v and u. Well, we have our formula that we were given here, that the projection of v onto u would just be equal to u dot v. So we have 2, -1, 4, dot v, 0, 1, 1/2, over the magnitude of u squared, which in other words is just u dot u, if we remember our properties. And then all of this is just multiplied by the vector of u. Well, we simplify this here. We get 2 times 0 plus -1 times 1 plus 4 times 1/2 all over 4, or 2 times 2, times plus -1 times -1 plus 4 times 4 times the vector of 2, -1, 4, which simplifies down into 2 minus 1, which is 1 over 4 plus 1 plus 16, 21 times 2, -1, 4, which you could distribute this out, but I think this is simple enough. But if you really want to look at it, you have now the vector 2 over 21, -1 over 21, 4 over 21. And this is your new vector that is v projected down onto u. Just like how this picture here, we would have this v onto u, this little squiggly component there.